Hey, this is Travis. In the last video, we talked about Bitcoin. We talked about how it is solving for a simple use case as a decentralized digital currency. It is the first blockchain that ever came onto the scene in 2009, released by an anonymous person named Satoshi Nakamoto. This was blockchain 1.0, the first blockchain. Now we're moving on to blockchain 2.0. And this era was initiated by Ethereum. It was the advent of smart contract blockchains. So let's get into it. As I said, Bitcoin is a simple use case. It is a simple blockchain, relatively speaking, and it solves for a decentralized digital currency, which is a store of value. Ethereum comes in and it adds a layer of complexity on top of it. So the founder, Vitalik Buterin, who launched Ethereum in 2015, he was an early adopter of Bitcoin, but he knew that there would be some other use cases that blockchains could solve for, additional use cases beyond just a digital currency. So let's talk about these two. Let's compare them by way of analogy. Ethereum is like a smartphone, and Bitcoin is like an app on your smartphone. So Bitcoin is kind of like a calculator app on your smartphone. It is limited use case. And Ethereum is the smartphone itself, where third-party developers can deploy decentralized applications to it and increase the utility of the overall platform with applications. It's more general purpose than Bitcoin. So Ethereum's a platform and Bitcoin is like an app. But they're both blockchains, and so they're similar in many regards. They're both open source software. They both are a network of nodes running their blockchain software. And they're also public ledgers or public blockchains. So they're very similar in many regards. But, just the use cases are different between these blockchains. And then also the cultures, the communities behind them have different philosophies and ethos. So Bitcoin is more conservative. Bitcoin is currently worth $786 billion. It has been worth over $1 trillion at some points. And they're more conservative in that they don't want to break what they have. What they have is working just fine. And they believe that Bitcoin solves a totally worthy use case of digital store of value, and they're content with that. Now, Ethereum, on the other hand, has a totally different developing culture where they want to push the use cases for blockchain. They want to see what's possible with Web3. And smart contract blockchains really are what enable what I talk about, what I refer to when I say Web3 ecosystems that are made up of decentralized applications. So Ethereum has a much more aggressive technical roadmap than Bitcoin, and the ethos there is to move fast and break things. They're trying to push the envelope. Ethereum is the most dominant smart contract blockchain. Right now, they are coming in at number 2, worth around $370 billion. Number 2 in terms of all blockchains, just underneath Bitcoin. But they're the most dominant smart contract blockchain. And let's talk about how Ether, the native cryptocurrency, has value. So Ethereum is general purpose, meaning that it can run any number of applications. Third-party developers can code a decentralized application and deploy that code to the Ethereum blockchain in something called smart contracts. And the Ethereum blockchain, or Ethereum, is called the Ethereum virtual machine, the EVM, will run these smart contracts. It can actually run that code. And the sky's the limit. Anything that these developers come up with in code, Ethereum nodes are going to try to actually execute that program. The problem with general purpose computing is that the programs are never guaranteed to come to an end state. They can continuously loop forever. And if a program does continuously loop forever, if a smart contract does, then this would tie up the Ethereum nodes from processing any other transactions on the Bitcoin network. They would all just be in this infinite loop running this smart contract program. This is a problem because a malicious developer or just an incompetent developer who deploys bad smart contract code to Ethereum could essentially halt the Ethereum blockchain for good. And this is something called a denial of service attack. It is an attack vector that all blockchains need to be aware of. Ethereum solves this denial of service problem with the currency and with the native currency Ether and what Ethereum does is it meters the amount of computation that people consume of the Ethereum nodes. So the more computing resources that you're tying up use it with an Ethereum node, the more Ether that you're going to have to pay to have that transaction processed. So let's just look at a couple really simple examples, right? So to send Ether to another account, I have to pay a network fee of $4. This is the ETH that I have to pay because this is the amount of, because they already know how much computation this send transaction is going to take, and they're going to charge me 0.001513 ETH to do so. Now, it's proportional to the amount of computation, right? So a send transaction is very simple. It requires only a small amount of computation. But if we go to something more complex, like a decentralized application like Uniswap, where I want to swap my Ethereum for another token, Web3 token, 1inch in this case, then I'm going to have to pay $19.65 to do this swap. It's because this Uniswap transaction requires much more computation from the Ethereum nodes than a simple send transaction. Uniswap has multiple smart contracts on the back end, so when I send this transaction, it could call multiple smart contracts and have to run multiple lines of code in order to execute this transaction. So you can see that things become more expensive the more complex my transaction is. So Ether is a digital currency like Bitcoin. It could be considered a store of value potentially. Different Ethereum wallet addresses have different balances of Ether, just like Bitcoin wallets have different balances of Bitcoin. But Ether has an added utility on top of Bitcoin in that it powers smart contracts. It powers decentralized applications. End users have to pay, they have to consume Ether in order to utilize the Web3 ecosystem built on top of Ethereum. And this is why Ethereum has a different investment thesis than Bitcoin. Bitcoin has a fixed supply of 21 million. Therefore, people consider it a store of value. That is why they associate value with Bitcoin. Ethereum, on the other hand, the demand for Ether increases if the demand for decentralized applications increase. So you have developers creating all of these brilliant decentralized products and deploying them to Ethereum. And Ethereum is just a platform that runs these products. But in order for end users to access the decentralized services, they're going to have to be spending Ether. So the more end user demand, or the more demand to use these decentralized services built on Ethereum, the higher the price of Ether should go in theory, right? This is very simple mental model to think of, but you can start to see how Ethereum as a platform and its native cryptocurrency Ether has value. But let's return now to network fees on Ethereum and talk about one of the major pain points with Ethereum as a platform today. So we know that Ethereum nodes, take in incoming transactions from clients and then put those transactions into blocks. But every block has a maximum amount of transactions it can fit within it. So there's a finite amount of Ethereum block space. And blocks are created every 12 and 14 seconds. So eventually you could get to overflow transactions. But the cost to get your transaction processed in a timely manner is always going to be increasing as more transactions flow into the network. Essentially, Ethereum can only process 30 transactions per second. So any transactions more than that, and there's going to be an overflow of transactions, and now we're starting to drive up the price of the network fees. So this network fee of Uniswap that I just showed, $17.96, you might have seen when I showed it several seconds ago that it was $19.28. This is because it's changing based on the dynamic demand of Ethereum block space, essentially. So as I said, the demand for Ethereum is going to increase the demand for Ethereum block space. Those two things are connected. And that now we're really coming up to 100% utilization of the Ethereum block space. This is going to increase the network fees. And we've seen in the past couple years that the network fees have become too expensive for the average user. So there was one day, I think the average transaction fee on October 25th, 2021 was $49.27. So personally, I've seen it to where to transfer Ether from one wallet to another costs $30 worth of ETH. And to do more complex transactions like utilize decentralized apps like Aave, which is where you can earn interest on your crypto, it would cost me several $100s just to submit one transaction and move some crypto around on Aave. This made it to where it wasn't even useful for me to submit that transaction in the first place. It was too expensive. The amount of crypto that I was transacting was smaller than the amount of the transaction fee to submit it. And this becomes a problem, especially for the average user who isn't transacting large amounts of crypto. So what's happening now is that since the demand for layer 1 Ethereum has increased so much that it's starting to become prohibitively expensive for most people to actually use Ethereum. And this is why it's the main pain point today. This brings us to something called layer 2s, where it's one solution to scaling the Ethereum blockchain in the short to intermediate term. We have a lot of demand for layer 1 Ethereum, and then we build layer 2 technologies on top that process a lot of transactions and then just send one transaction to the layer 1 blockchain. So in this way, it is removing load, reducing load on the layer 1 and putting that load onto a layer 2, which can process many more transactions per second. This is one solution to scaling the Ethereum blockchain, but also Ethereum is going to go through a major software update. It actually is in the middle of this software update, and it will complete it sometime in the year 2022. And it's transitioning from Ethereum to Ethereum 2.0. So the software architecture is totally going to change. Right now, there's just one blockchain, but what Ethereum 2.0 will be is a central. It's going to be a main beacon chain, and then there are going to be 64 sharded chains connected to that beacon chain. These sharded chains are kind of similar to the layer 2 I was just talking about. The 64 sharded chains are going to be able to process transactions in parallel to one another. So you can see how you're basically multiplying the amount of transactions that can be processed at least by 64. But there's probably some more technical details that I'm not really digging into behind that. But also, Ethereum is going to transition its consensus mechanism from proof of work, which is what we talked about in the previous video with Bitcoin, to something called proof of stake. Okay, and we're going to get into the details of proof of stake in the next video, but understand that these are major software upgrades that Ethereum itself is undergoing. And this plus these layer 2 solutions that have been built on top of Ethereum, developers believe will increase Ethereum's TPS, transactions per second, from 30 to 100,000. And when we see this, then the network fees should decrease, right? If demand stays the same, but we can process more transactions per second, then the network fees will decrease and we are up and running again, and many people can use Ethereum. So we talked about Ethereum. It is the first smart contract blockchain. It has a native cryptocurrency called Ether, which is used to access the decentralized applications that have been deployed to the Ethereum blockchain. There is a problem, though, with this Ether, with these network Ether fees. They are costing too much for the average person to use Ethereum. So Ethereum has been in the process of implementing solutions to this. They are trying to scale the blockchain with layer 2s and then also a complete reworking of the software architecture of Ethereum from Ethereum to Ethereum 2. And transitioning to Ethereum 2 is going to be a transition for us from blockchain 2 to blockchain 3.0. Ethereum 2.0 is definitely contained within this category, but in the next video, we're also going to talk about these other emerging layer 1s that are competing for dominance in this new blockchain 3.0 era. Totally new founding teams, all with different design philosophies and approaches for solving these blockchain problems that we're going to talk about later. But we've already talked about the blockchain problem of scalability. We want to make things as cheap and transactions as fast as possible for end users. And then also we're going to talk about something else called blockchain interoperability. But just understand that we have many other layer 1 blockchains like Polkadot, Solana, Luna, Cardano, Algorand, Avalanche, Cosmos. We have many others and more that are going to compete in this space. So let's talk about what the next era of blockchains is going to cover. Thank you.